Welcome back, everyone. In the next lecture, we are going to look at another non-parametric statistical test known as the Friedman Test. And we use this test when we have more than two groups of data, and this time this data is going to be paired, as opposed to unpaired, which is when we would use the Kruskal-Wallis test. Our objective for this lecture is to appraise if a Friedman statistical test was appropriate for analyzing data provided in a scientific journal. The Friedman test is used to analyze data obtained when subjects participate in 3 or more treatment groups. So it's going to be the same group of subjects that are participating in 3 or more treatment groups. And again, these observations are ranked, and the Friedman test statistic, which is calculated and known as a chi-square R, and this is calculated in a similar way to the Kruskal-Wallis H-test statistic, and so again, we are not going to be required to calculate this for the purpose of this class. This value of chi-square R is then compared with the chi-square critical value table to assess the statistical significance. So looking at an example, we are testing again our Miracle pain reliever drug at doses of 10 milligrams and 20 milligrams compared with placebo. And this is in patients who are suffering from a headache. Patients were given each of the treatments for 1 day with washout periods in between each of the treatments. Pain scores were obtained for each patient in the 3 groups 1 hour after administration of the drug or placebo, and their pain scores are listed below. So very similar to our Kruskal-Wallis actually, except it's the same participants in each group. So we have our group 1, which is placebo again, group 2, which is 10 milligrams, and group 3, which is 20 milligrams. Again, we want to go through our analysis methodology. We want to make sure that no assumptions are violated. So we have non-parametric data, and we have subjects that are participating in 3 or more treatment groups. We want to state the null and alternative hypotheses. So our null hypothesis is that there is no difference in pain scores between the 3 treatment groups. Our alternative hypothesis is that there is a difference in pain scores between the 3 groups. We want to state our alpha, which again is 0.05, and we want to calculate our degrees of freedom, which is the same as how we calculated it for the Kruskal-Wallis. So there are 3 different treatment groups, and so it would be 3 minus 1, which is 2. And we want to find the critical chi-square value. So again, we turn to our chi-square table. We are using a significance level of 0.05, and we have 2 degrees of freedom. So again, our chi-square value is 5.99. So since our chi-square value is 5.99, this means that if our chi-square R value, so our test statistic value, is greater than 5.99, then we can reject the null hypothesis. So next we have to calculate the chi-square R statistic. So this time when we do the rankings, we rank across the row since it is the same patient receiving all 3 treatments here. They're only going to get a rank of 1, 2, or 3 going across the row unless there is a tie. So for example, for our first participant here, they have a pain score of 10 with the placebo, 7 getting the 10 milligrams, and 3 receiving the 20 milligrams. So 3 is the lowest pain score, it would get a rank of 1. 7 is the middle pain score, so it would be getting a rank of 2. And 10 is the highest pain score, so they would get a rank of 3. Again, if there is a tie, meaning they have the same pain score between 2 of the treatments, then we split the rank again. So we get 1.5 and 1.5 for each one of these, and then the pain score of 6 would get a rank of 3. And again, the chi-square R statistic is calculated using a unique formula, which we do not need to know for the sake of this class. So we're going to use an online program to calculate this for us. And this is the same program that we used for the Kruskal-Wallis. Okay, so from here, we go under ordinal data on the left-hand side of the screen here, and we scroll down to the Friedman test here. And since we have 3 different treatment groups, we're going to select for k equals to 3. And it will prompt us to enter a value of n, which is going to be 6. And we only have to enter it once this time because there are the same 6 participants that are receiving each of the different treatments. So we enter 6, And then we scroll down, and here's where we will enter our raw data. So our 6 different pain scores for each of the treatment groups will go here. I've already filled one out already. Okay, so we have the 3 different groups here with all their respective pain scores, and we hit calculate. And we can see here that our chi-square, our test statistic, is equal to 9.08. Again, it calculates for us the degrees of freedom, which we know are 2. Also calculates a p-value for us, and since we see that 9.08 is greater than our chi-square value of 5.99, we know that we can reject the null hypothesis and that we do have a statistically significant difference between the groups. And this is reflected in the p-value here too, which is less than 0.05. So again, our chi-square R value is equal to 9.08. It's greater than our chi-square critical value of 5.99. We can reject the null hypothesis and state that there is a statistically significant difference between the groups. In our next lecture, we are going to cover the chi-square now, so stay tuned for that.